everyone. Today, let's solve function limits starting from very simple example number one, moving gradually to more difficult ones until one on the intermediate level. Okay, so case number one, as you can see, limit for x approaching 1, and this is a simple expression, polynomial without any denominator. So for this kind of expression, like here, we can simply plug in the value of x, which is 1. So it will be 3 times 1 to the power of 2 minus 5 times 1, because x is approaching 1, so we can replace it. We can replace x with 1, plus 1. So it equals 3 times 1 to the power of 2 is 1, so 3 times 1 is 1 minus 5 is 3 times 1 is 3 minus 5 is negative 2 plus 1 equals negative 1. And this is the answer. Not advanced calculation, just plugging in the values. Okay, so solution is -1. The next one is a little bit more challenging, but still not very difficult. We cannot plug in values here. As you can see, x approaches 2. So if you take 2 squared minus 4 divided by 2 minus 2, the answer will be 0 over 0. And this is not allowed in calculating limits. It leads to the faulty solutions. So we need to find a way how to get rid of this denominator here. So what will be very helpful is what you can see here. We have table of algebraic identities, and we will use difference of squares, this one here, which tells us this a squared minus b squared equals a plus b times a minus b. So this expression, this is our a and b, so they are already squared, so we can remove the square by multiplying them. So it will be the same as, let's change it to black. It will be the same as equals x plus 2 in brackets x minus 2 over x minus 2. And now you can see that we can already simplify this expression here. We can cancel out x minus 2. And what will be left is x plus 2. And when you have left x plus 2, you can plug the values for this expression. So it will be, if x is approaching 2, so it will be 2 plus 2, because x is 2. Therefore, the answer is 4. We solved that limit by using difference of squares, which is very helpful in solving limits. And case number 3, a little bit more difficult, I think, because we will not use algebraic identity, but we will use method called factoring. Okay, so I'll just write it here. This is called factoring, and we need to remove, factor out the highest exponent, which here is x. X, so we'll factor out x. So factoring is we write x before the bracket, write x. Here we write 2 and plus 3 over x, because we remove x and 3 didn't have an x, so we need to write it as a denominator. Then it will be the same factoring x. Here we will write 1 plus 1 over x. Okay, so what you can observe here, that x's will cancel out because they are factors. They are factors, so they can cancel out. And we have 2 and 1 left. But what to do with this? How should we approach this problem when we have this 3 over x and when we have 1 over x? What to do with this? So it's very important to understand that in this case, x approaches infinity. So infinity is a very huge number. So if you write a number, okay, let's make it black, number over infinity, n can stand for a number, number over infinity, L equals number close to 0, because infinity is very, very large number. So if you divide number by infinity, you will obtain a very small number, just like, for example, 1 over infinity. So infinity, this symbol, yes, this is infinity. 1 over infinity, or any number, 2 over infinity, 3 over infinity, it will still be close to 0 because it's a reciprocal number. You can see this is the concept of reciprocal number, which change it. So if you make a reciprocal of 0, then you would get infinity. But here you do reciprocal of infinity. That's why you get 0. So once you get 0, you can write here that 3 over x is close to 0, so we can ignore this solution. What is on the left is 2 over 1, right? 2 over 1 equals 2. And this is our final solution. We found it. So remember, when you solve these cases, factor out the highest exponent. If it's x squared, you put x squared before. But here's no x squared, so just put x before the bracket. And then you see if you can obtain 0, if you get 0 in this kind of fractions, you eliminate them in your calculation because they don't matter. They don't change they change, or they don't influence the result. Okay, so let's do the most challenging one, this one. So for this we will use a method called conjugate. We have to multiply it by conjugate, which still will be very similar to this difference of square, right? We were gonna do it similar way as we did number 2. However, we will need to multiply numerator times conjugate, and we will also need to create conjugate, the same conjugate for denominator. So that will be new. So let's just write it here. Again, x approaches infinity, so it's gonna be x 9x squared plus 4x in a square root minus 3x. Right, so need to multiply by conjugate. Conjugate is, you can treat this part here. This is your A, this is your B, because you have minus here, which will look very similar to a squared minus b squared, but it just looks so complex here because it's under square root, but it can be simplified. So conjugate will be again the same, but we will have plus 3x, right? Instead of negative 3x, we'll write plus 3x, and here we'll write the same 9x squared plus 4x. This is all in the numerator, and this expression will be written in the denominator. 9x squared plus 4x square root plus 3x. So what does it equal to? Please observe, again we have a and b. So we take a times a b times b, and we will simplify it. We will get rid of this square root. We want to get rid of this square root. It's not necessary. It's disturbing us. So you can notice that it will be in the numerator 9, after simplification, 9x squared plus 4x minus 9x squared. Perfect. And here in the denominator we write again this expression, but we will take care of it later. Now we're doing this, so as you can see we can eliminate 9x squared. This will be eliminated because 9 minus 9 is 0. So what is left is only 4x in the numerator over this conjugate below. We still have the square root in the denominator, which will be 9x squared plus 4x minus 3x. The problem was, yes, that we have, I made a little mistake, but it doesn't matter now. Little mistake was that I wrote plus. Originally it was minus 3, right? Minus 3x. So yeah, if it's minus 3, at the moment everything is correct. Conjugate will be positive, right? It has to be positive, and that one remain positive here. So at the moment it's all okay. It's all good. So how to get rid of this? How to get rid of this square root here? So forget 4x at the moment. For a moment, forget about 4x. Now let's think how to factor out this expression so that we will eliminate square root. So first we can, under the square root, we factor x squared. Here, then you have only, in brackets, you write only 9 plus 4 divided by x. And this expression equals, now you can take the square root, it will be on x, you will take x outside the square root. First you wrote x squared inside the square root. Now you have to take this square root out of the, you have to take this exponent, power of 2, take it out of the square root. Then you will have square root then you will have here square root 9 plus 4 over x plus 3. Then we write in brackets, we eliminate 3x because we factor out x before the whole expression. So we have only 3. So, and here in the numerator we can write 4x. Okay, now it looks like this, pretty clean. So what is happening here? You can cancel out x's, right? This x is here and that x, they can be eliminated. So you have 4 over square root 9 plus 4x plus 3. So you will have 3 plus 4x over x plus 3 in the denominator. Again, this expression will be ignored because x is infinity and number over infinity approaches 0. Right? So we can ignore it. So we have only 3 plus 3. So we have, what is left is 4 in the numerator with 3 plus 3, 6 in the denominator. Therefore, after further simplification, it's 2/3. And this is the answer. The limit for this function here is 2/3. We solved it. The most challenging one, but you use very similar method to find the conjugate based on difference of squares. And be careful when you factor, especially when you factor this expression inside the square. Remember, factor expression first inside the square root, and then take it out. Take it out of the square root, and everything will become clear. Okay. I hope you find this video useful. That's all for today. Next video, maybe we'll do more challenging limits. That's all for today. Thank you.